So this is our Lab 2 assignment, and we were given 4 questions, mainly about uninformed search. Informed search. And from this assignment, I learned how the A-star search algorithms work, what are heuristics, and basically more about informed search algorithms. So let's go through the questions. The first question asked me to to tell the difference between uninformed and informed search. And from what I understand about these terms, in the uninformed search, you are like the algorithm does not have information about the goal, and basically does not have a direction towards the goal. So it starts from a start node and it just searches all the way until it finds a goal node. And examples of algorithms like this are the depth first search and the breadth first search. And informed searches, on the other hand, have information about the goal and they utilize that information to get a direction to move towards while the algorithm is running. And such types of informed search algorithms are like the greedy best first search algorithm or the A-star search algorithm. The second question asked me, what is a heuristic? And a heuristic is an estimate of the cost from a given state in the search space to the goal state, and it helps the informed search algorithms find the goal node. So it gives them a direction as well. And I remember you mentioning in class that there are multiple ways of finding a heuristic value, and some of them include like the Euclidean distance or the Manhattan distance. And the third question is, when is a heuristic admissible? And a heuristic is admissible if it is non-negative and it is always an underestimate, or it is equal to the actual shortest cost from the current state to the goal state. And if a heuristic is admissible, it should always provide, if the heuristic is admissible, it should ensure that algorithms like the A-star search algorithm always provide the optimal solution if that optimal solution does exist. Then in the second question, we were given this graph and we were asked to label the costs. And I put all my working down here, but I'll go through one of them because I'm a bit short of time as well. So for example, I need to find the distance from C to F, the cost. So we're told that the first value in this array is F. So we have the formula Fn is equals to cost n plus Hn. So here 5 is F. We have to find the cost, and the heuristic value is 2. So the cost is 5 minus 2, which is 3. And quick thing to note that 3 is the total cost from A, which is the start node, to F, which is the goal node. And what we have to do is find the cost from C to F only. And how do I do that? I do total distance minus A to C, which is 3 minus 2, which is 1. So C to F is 1. And that's exactly what I did for the rest of them. And I've put all my explanations here. Then the next question I was asked is the heuristic value up admissible in the previous graph, and why or why not? And in this graph, it is admissible because, first of all heuristic values are non-negative. And secondly, they're always less than or equal to the distance from, they're always less than or equal to the shortest cost from the current state to goal state. Let's look through them quickly. For D, the heuristic value is 3, while the actual cost is 5. So this is acceptable. Here, the heuristic value is 3 when the actual cost is 4. So it's acceptable. Here, the heuristic cost is 3 when the actual cost is 3. That's acceptable. Here, the heuristic cost is 1 when the actual cost is also 1. So that's admissible. Here, the heuristic cost is 2 when the actual cost is also 2. So that's admissible. And here, it's 0 when the actual cost is 0 because this is the goal node, which is also correct. So in all cases, the heuristic value is admissible. And the last question we were asked was to represent this value in this problem in AI space. And that's what I've done here. And from what I know about the A-star search algorithm is, if you go back here, it will follow the path with the shortest F. So if we start at A, here F is 4 and here F is 3. So it should go from A to C. And then from here, F is 3 and here F is 5. So from C to E it's 3 and from C to F it's 5. So it should go towards E. So the path will be A, C, E. And we can observe that in the algorithm here. So I can just pick the A-star search. I can go step. It explores B and C. It sees C has a shorter heuristic, so it goes that way. So now we're in C. It explores E and F. It sees that E has a shorter heuristic, so it goes there. And ta-da, we found the path A, C, E. And the path, the cost is 3. Perfect. Thank you.